Today we're going to start a discussion on classes. Okay, in the previous session, I talked to you about the three things that we're going to talk as we move along. And those three things were basically modules, classes, and packages. And so we got some brief introduction to modules in the previous one. Today we start with the classes, and in the next one we'll begin with the packages as well. And then we will incrementally bring the complexity to these three concepts to try to build something slightly bigger. So today the topic is classes. Classes and object-oriented programming. So let's begin with the classes, concept of classes first, and then let's talk about OOP in a second. So what is a class? If you have any experience with any programming languages, especially like C++, Java, then you would know that there is a concept of classes in all of these languages. What class lets you do is that it lets you create a custom data type. Okay, the Python, for example, has a good built-in collection of the various types of data. You have numbers, for example, you have numbers, you have lists, you have dictionaries, and you have sets and files, iterators, generators, all kind of things. But what if you have a real world object that you want to model that doesn't fit in any of these, or it is an aggregation of some of these? For example, you may be trying to create a type called person. A person might have a name. Name is a string, for example. So it has a string, and then it might be having, let's say, some kind of a context, which is a collection inside a list. So it's a composite type and it's a custom type. The Python does not know anything about it until you define what this thing is. So, so in this case, uh, we use what we call classes. Okay, and just give me 1 second, just 1 second. So let's begin by defining a simple class, a one-line class. Okay, and for that, I'm just going to go to my terminal and essentially try it out here. Let's fire up the terminal and we have, let's create a simple class. So I'm going to say class, and let's call this class, let's say uh, person, and put a colon and just one liner, just like, let's say pass. So this is like an empty class at the moment. And if you try to see what this is, you will get that this is a class called person. And when you want to instantiate an object of that class, then you will do it. It's similar to how you did for, let's say, a set. Once you want to create a set, you can say s equals to set. In a similar way, you will instantiate an object p is equals to person. And then now p is a person object, as you can see. And this is the memory address where it is. So it doesn't matter, but essentially this is a person object at the moment. So this is a very simple class which does nothing. It is just a template. And as we move along, let's try to build this class up. So as I mentioned, class is going to be a template for instantiating a type of objects of the type of the class that you have defined. So suppose you want to create people out of person. So suppose let's say there is a person called, let's say, Frodo, which will be a person type of an object. All the attributes corresponding to Frodo will be encapsulated in the Frodo object. And that Frodo object will take its, like, the configurations, or what you call the structure actually, from this template here. So let's go on to define this in as a first class. And as we move along, you will notice there are few things that will come up which I may have to explain little later. Okay, I will not be maybe not may not be able to explain it right away, but I may take some time to explain it later on. But let's go. Let's define the very first class. Let's call my class. So first of all, the naming convention. So in order to define a class, what you do is you say class, which is a keyword, and then you define your class saying my class. Now, what is this? This is called Pascal naming convention, right? So in Pascal naming convention, you begin with the caps letter, and then each word begins with a caps letter. Okay, and if let's say you wanted to define something a bigger class, and let's say you want to say let's say electric cars, so it will be something like electric cars. That would be the name how you will define it. So this is different from this naming convention is different from what you have been seeing all this while. But that's the naming convention in Python for defining the classes. Okay, so you have a class called my class, and let's put this here. Now, currently this class doesn't have anything, so you want to put some attributes, right? So what is the difference between two people, right? Or what is the difference between, let's say, any two people, let's say Frodo and Sam? Any two objects, like object one and object two. What makes them different are the attributes that these objects contain. They are different. So, for example, I may have a different height compared to the other person. I may have a different weight. I may have a different passport, or all the attributes that are associated with me makes me one object instance versus someone else. Right. So, how do we define these attributes? There are uh, attributes that we're going to define in a special method to begin with, and this method is called init. Now, this I'm going to explain this what this is in a second, and we're going to put the attributes that are going to define this particular class by writing self dot let's say x equals to suppose none, self dot y equals to none, and so you put self here as well. What this is saying is that the init method is used to initialize the object of a class. So now when later on I'm going to say, let's say C1, or let's say A equals to my class, then this init method is called to construct an object of my class type. And in that object, two attributes have been put. One is called X and one is called Y. The self keyword, I will explain in a second why it's used, but you can think of this as something like a this in Java and C++. But this is just saying that this X is not a local variable of the function, but this is actually a attribute of the class itself. So you're writing that this self means that this is an attribute of this class. And if you have any other variable, something like, let's say, z equals to, you have something like z is equals to 5, then z is equals to 5 is just a constant, which is not part of, which is not an attribute for this class. It will be destroyed as soon as the init is done doing its work. So currently, let's suppose say a equals to this and b is equals to my class, and we can say print a and suppose print b. So when we execute this, all you're going to get is that, okay, we have created two objects of a and b type. So essentially when you have this, so essentially when you have this, when you encounter this line here, this essentially goes to the definition of my class, and an object of my class is instantiated in the memory, and that has an x and a y as defining values, and then a starts pointing to that object. Similarly, when the next line defines it again, a new object which is completely different from the other object x and y, and then you have b pointing to that new object, right? So you have these two objects now. And
so how this differs from attributes, like objects and attributes, in which way you're using it?
so right now they are none at the moment, but for each one we may have different values, right?
So is that self becoming A right now?
This self,
Yes.
so this self is just a reference to the current object. As we will explore the functions, you will understand what I'm saying. So at the moment, just think of this self as that when you put self dot an attribute name, this means that this is an attribute of the class and not a local variable. That's all it means right now. And the init function is what Python is using to initialize this. So the first line here is define init and self. Okay, self here means that this particular class. And you say self.x equals to none and self.y equals to none. Any method that you will define inside a class, any method, will have self as the very first argument of that function. And you will never pass it. For example, you never passed it while creating my class. Python will pass it automatically. And this will become extremely clear as we move along. Suppose we want to assign something to it. So we can just say a dot x is equals to, let's say, 100, and a dot y is equals to 200. Similarly, we can say b dot x is equals to something. This is a string, and b dot y is equals to 3.14. So if we run this code, we are still seeing the same thing, but now these two things differ. So we can write print a dot x comma b dot y, and then we can say b dot x comma b dot y. So when you run this, you will notice that the a object contains the values 100 and 200, and the b object contains something else here. So now we have initialized those values by explicitly assigning those values. So this is 1 second. Okay, yeah, let's go. So this is now 100, and this is 200, and this is, let's say, 500 and 600. So then you have two objects which have different values now.
Does the object address change every time?
Anytime you create a new object?
So in your console, you had the object address. So the first time it was different, and the second time it was a different value.
For P, it should not. For one object, it will always be same.
Like in the Thorny console, the first time when we had print A and B, and the second time A and B, the object.
Yeah, I mean, so okay. So your question is, yes, it will change. So remember what happens when you will run this. This program ran and it terminated. Now when you run it again, these objects will be created again, right? And then so somehow this is same, but it doesn't have to be same. Right now you see this, they are same, but they don't have to be same because the program terminated after that. And this was a new instantiation. So these will be different, and two objects of course will be different because they are on different location. But I think even this should have been different. Not sure why this is same. Maybe there must be some.
They are different.
They are different.
Oh yeah, they are different actually. I'm just looking at the suffix. Okay. Cool.
And what is the difference between A is equal to my class bracket and A is equal to my class? When I did A is equal to my class, that still shows as a class, but doesn't give an object actually.
So yeah, that's what exactly what you're doing. So suppose person, right? What is a person? Person is a class. If you say x equals to person, then essentially x has become that class. When you want to instantiate it, then you have to put this bracket. Now the x is an object of that class, right?
Yes, okay. So it's object and class difference.
Yeah.
Okay.
The person by itself just only mean func this. So if you, let's say, define a function, let's say define func, and say, let's say, return none. Suppose you have this. If you just func, then this is just a function which is pointing to a function object. If you do this, then the function is executed. That's the difference. All right, so at this point, I'm going to give you a minute. Try this, and let me know if you have any questions, and feel free to discuss.
The first time when we call my class colon pass, what is that pass keyword?
So pass is an empty statement. It can fill in anywhere where you want. So suppose I want to play around. I say, let's say, def func, and suppose I hit enter. This is a problem because something was expected here. So pass can fill in anything. It is just considered an empty statement. You just use it to fill the syntax for the time being, so that later on you can come back and then put more stuff there. That's all. It's a syntactical completion syntax completion tool, essentially. You can say, think of that.
Thanks.
Is it unique for Python to have this path?
Yes.
I haven't seen in
Yeah.
other.
It's unique. I think it's pretty unique to Python. I have not seen it either.
I think it's
Unless, it's there in Swift or JavaScript or something like that. But I have not seen it in Java or C++. So what is object-oriented programming? There is what you call procedural programming, or programming or scripting, in which what happens is, when you write a program, all you're doing is you're telling a list of commands. You create a script and you say command 1, command 2, command 3. You may create some kind of a variable x equals to 3, and then later on use it in some kind of command n. But all you are doing is, from top to bottom, you have a sequence of commands that get executed. This may have if and else. So you may have if and else, or this may have a for loop as well. But this is one way of solving a problem. This works well in a simple program, or when you're writing some kind of a script to do certain simple operations. But anytime you want to model a complex situation, essentially what you will end up using is object-oriented programming. In object-oriented programming, the world is the program actually models a real-world situation, and each entity, so essentially the whole program is about different type of objects talking to each other to accomplish a task. You may have seen this several times. For example, let's say you're developing a web application of some sort. So there will be some kind of a resource, let's say a database. Usually there'll be some kind of a class called DB manager, which will be responsible for talking to database. And all the other things, for example, there is, let's say, something called, let's say, cart. There's a class called shopping cart, which wants to insert anything into DB. Then cart will essentially interact with the DB manager to insert that value inside the database. And similarly, the value, the response is returned back to the cart. If you want to, let's say, model a thing in a real world situation into a class, for example, let's say you're running some kind of a simulation, and let's say you want to do model a car, right? So the car is a type of an object. This object contains other object. So there is a object, there's the idea of composition. This class consists of another car class. For example, it might be a wheel class, or it can be an engine class, or it can be, let's say, steering class, if the spelling is correct. So this class will have all of these classes. So when you create a class object, essentially it will contain a wheel object. And a wheel object can have its own attributes. It can be composed of other classes, but it can have its own attributes. It can have, let's say, a color. It can have a size. Or it can have something like, let's say, features. So it allows certain things on the wheels themselves. And then you can have engine. Engine can have certain attributes. Or engine can have types. So it can be, let's say, so it can be capacity, like how many liters of engine of this is. So these are the engine attributes. So in this way, I mean, whenever you create any entity, whether it's the gaming or in a web app or in any other situation, you're essentially creating a bunch of objects. And those objects each are going to have some attributes and some functions, which are called methods. And different other objects can talk to this object to get some kind of work done by calling its methods. That's the real world. That's how you model any real world situation. And this paradigm itself is called object-oriented programming. Now, this I'm specifically talking about Python, but there are books which are dedicated to this. What this lets you do is it lets you really write program at scale and also maintain it. Later on, somebody may say, so you can express relationships here. You can have, let's say, a car object, and it can have certain attributes in it. Okay, so it can have, let's say, some generic type, let's say something like the color, and let's say weight, or type, whether it says, let's not put type actually. Let's say it has color, weight, and let's keep it with that. Then you might have something called electric car. Or let's say you may have a gasoline car. Once you have this situation, for example, and this is bound to happen in any big program, then you don't want to define the color and weight again. What you do is you have a basic template, and you can express is a relationship. And you can say that electric car is a car, a gasoline car is also a car. And then in this electric car, you can specifically put things which are specific to this car. You can write, let's say, an attribute called charge capacity. And here you can have, let's say, fuel capacity. So both of these objects are a type of car, and they also have their specific attributes in them, and they inherit the basic ones for the car. So this type of modeling is called inheritance. Similarly, you may have, let's say, a boat class, which has, let's say, a motor class in it. So there is a boat which has a motor class as well. So this type of has a relationship can also be explained in the form of classes, and this is called has a relationship, essentially is called composition. So object-oriented programming is essentially what you will be using for anything that when you write like uh, any significant code, and this is how you will be expressing relationships. And we will also see in the class how to do inheritance and polymorphism and all those things. But this very neatly lets you express the relationships between the different type of objects. Any questions?
That helps a lot. Thanks for that.
Does Python also support access controls like public private data types for an object of a class?
Python doesn't have a private type, but you can create something like that. There is a convention, but there is no language enforcement like Java or C++. In Java or C++, you have explicit access modifiers. So when you create a class in, let's say, Java, you can write just, let's say, my class, and then essentially when you can write something like private int, let's say age. So this private essentially means that nobody outside the class can just directly access it. But that's not the case with Java. Oh, that's not the case with Python. And but of course there's a way, and I will show you the way as we move along how to do that. This public and private is not enforced, but there's certain naming conventions that you can use to tell everybody that this is a private member and you're not supposed to touch it. Okay, let's improve this class. Suppose you want to create this class with some kind of an argument to begin with. Let's say if you're creating a person class, then you might be saying, okay, I should be able to pass, let's say, name. Instead of assigning it later on. So similarly, let's come to this class, for example, for a moment. Let's define this class. Let's call this person. One other difference in Python compared to Java is that in Java, the file name and the class name have to be the same. But in Python, essentially, file name can be anything. So I'm going to define a class called, let's say, person. And in the class person, I'm going to say, first of all, I'm going to define an init, __ init. And the first argument of the init is going to be self. The second argument, let's say, is the name. Okay. And so this is a variable. This is a local variable to the function. If I write name, then I will be able to get this variable. But if you want to create an instance variable for the class, then you'll have to write self.name equals to that name. So self.name is an instance variable, is an attribute for the class. And it is assigned this value of this name here. And you could have called it X as well. It would have been the same thing. So when you do that, and suppose you come back here and you say, now, okay, assign a person P1 with the name, let's say, and you say, let's say, print P1 and print P1 dot name. So when you do that, now you will notice that we have created an object, and also we have initialized the object in the very init code by passing some kind of an argument. So you can, so this allows you to create this type of an object. So if you, going back to the previous example, you could have said, let's say x comma y, and you could have assigned x here and y here. But now if you run this code, it's going to throw an error. It's going to throw an error, which is like a type error, where you're saying that now the init requires two positional arguments, x and y. And we are not providing those x and y. So we have to now provide those x and y. So we have to say, okay, let's say 5 and 10. Let's get rid of this. And when you define b, let's say you put 10 and 15, and then you can run this and you're good. If you want to keep default values, then you can use the concept of default as we discussed in the previous classes. You can say x equals to 100 is a default value. And let's say y is equals to 100 as another default value. So let's say if you create another class, c is equals to my, or just let's just change one of these. So in this case, if you don't provide anything, then the default value 100 and 100 will be passed, is in this. So now we have created a custom init code where we can supply a value and we can create a class of, create an object with those values. Any questions? Okay, I'm going to give you a minute to try this out yourself, and then we will try to develop a class. So let's come back to our code. We defined a function called last name, and last name does this.
I have a question. Is there anything like class method like in Java? Or is everything
Tell me, what do you mean by class method?
that if you have a variable and you change it in whatever instance, it changes for all the instance, like count?
You mean the static?
Yes, yeah. Yes, such a
There is, we'll come to it. There is a variable type, which, so there is a way you can define a variable which will work outside the context of an object. And you can, once you change it in one place, it gets reflected in all the objects. Yes, that will come up. So suppose we are modeling the person class, and let's write some more functions. Maybe suppose we, actually I want to create something else. I want to create a new type of class. Okay, this might not be relevant to all the people, but still it's a good thing to know. Okay, and so in this example, I'm going to create a data structure. Okay, so there is a data structure in when you study algorithms, a data structure called queue. A queue is a useful data structure wherever there is a scheduling problem. Right? Scheduling is a natural concept that occurs in every single system. You might, so suppose you might have a, let's say, a web server, and many people might be calling it. Let's say you might be going through, let's say, Google search, and a lot of people may be calling Google search, and it might be flooded with millions of queries every single second. Internally, it's queuing those messages. Internally, the application is queuing those messages and passing through some kind of an engine, then later on passing this one by one to some kind of an engine. That engine processes the result and shows the user the result back. So let's say a new request comes, it is added to the one side of it. And so the enqueuing operation happens on one side, and the dequeuing operation happens on the other side. If you want to get a coffee, let's say you go to Starbucks, essentially there is a queue. You're standing in that queue, you enter from the back of the queue. And the person at the front of the queue is the first one to get the coffee. And then as that queue moves along. So that queue structure is everywhere relevant. So suppose we have to create a queue, simple queue structure for integers. Okay, let's create that structure. The requirement for it is that I'm going to create a queue for, let's say, nums, just for nums for now. Okay, and the queue should support a method called enqueue. I'm just writing short enqueue, and it should support a method called dequeue. When you enqueue something, basically add the number to the back of queue. And essentially this is, the other one is remove the number from front of queue. So this is a collection. You keep enqueuing, and when you dequeue, you get the number that was inserted the very first time. So it's a very good problem in that way. So we're going to create a data structure, which is our own custom data structure, which is going to do this for us. And suppose it has another method that you can query at any time called size. Basically, it returns the size of queue. Okay, so think of it just like a list. List has a len method, and you can use a len method on the list and all that. So similarly, we're going to create a simple queue. Okay, and suppose we create an object of this. We can say, okay, insert 5, and then insert 6, insert 7, and then insert 1, and then we say dequeue. So suppose the person who's giving coffee is now available to say, okay, whoever is the front of the queue, come. So the front of the queue was this number. So that number comes back from the queue. So we have to remember this order of this, the way the items came into the queue, and we have to dequeue them. And this type of a structure is called first in, first out. Whoever got into the queue first is going to be the first one to come out. So let's develop that data structure. So I'm going to create a class for this, and this class is called, as the name says, queue. Now, how do we define this queue? Okay, let's think about how can we achieve the goal that we are trying to achieve here. So how can we do this internally is, outside world will not know. Outside world will see our data structure called queue. So a person standing here will just know that this is a queue. Internally, we can play around to achieve the result. And we can play around by just creating, let's say, some kind of an array. In Python, the list is a very powerful data structure. Okay, when you create a list, you can essentially give the behavior of a queue. Let's say anytime somebody wants to come in to the queue, you can insert them on the 0 index. And that will automatically shuffle the rest of the items in one front. So whenever somebody is enqueuing, you can insert them on the 0th index. And anytime somebody is dequeuing, you can just check the last element and return it. Right, so essentially, this is the queue. Let's say these are the entities here. The very first person comes to the back of the queue. And so this person comes here. When this person wants to come, they come to this part of the queue, and this person moves one step forward. And at some point of time, when you want to, let's say, dequeue, whatever is the last element in the array is returned back. last element in the list is returned back. So this way we can do an NQ and DQ. Right? And to simply play around with this, suppose I define a list. And if I want to say, let's say NQ, then I'm just saying L dot insert 0, let's say 1. Then L dot insert 0, 2. Now notice 1 is at the back. 1 is at the front right now. If we see the front from the right, then 1 is at the front right now. If we say L dot insert 0, 3 in queuing, then 1 is still at the front. If we say L dot pop, this removes the first element, then removes the second element, then removes the third element. So essentially, you are able to simulate this using just a list. So we are going to use this list, and we are going to internally play around with this list in a way that it gives the outside world an illusion that they are enqueuing and dequeuing, and we're just playing around with this list. So let's create this structure. I'm going to create an init method with self. Initially, when you create a queue, nothing needs to happen. So I'll just say, okay, internally, I'm going to create an array. I'm just calling it array, or you can call it something else. You can call it whatever, queue, for example. And this is just an empty list. When you initialize a queue, that's just an empty list. Now I'm going to write the methods. I'm going to say, okay, enqueue. When somebody wants to call enqueue, they will have to give me something to queue. So they will have to give me some kind of a number. Suppose this is the number that they give me. So then I can just say, okay, whatever the self.queue is, insert into this. So this is just a list. In this list, insert at the index 0, the item X. And then I'm going to say self def dequeue. Self. This doesn't need any argument. When you're saying dequeue, just return the last element. So I'm going to say self.queue.pop. So this is the self.queue, which is this queue, and we say pop the last element out. And finally, let's say somebody says size. Okay, what is the size of the queue? Then all we have to do is just return. You should put a return here as well. Return len of queue dot size. So internally, Python can compute the length of this queue, self.queue. Sorry, my mistake. What am I doing? Internally, Python can compute the length of self.queue, and then we just return it. Outside world doesn't need to know what is happening here. There is a problem in this code, but we will see when it comes up. Any questions in this implementation so far? Okay, I guess not. So let's create a queue object. We say queue, okay, q1 is equals to queue. And I'm going to say q1 dot enqueue 1. Then I'm going to say q1.enqueue2, and then q1.enqueue3, and then let's say dequeue. And we say print of that. Right? So in this case, the 1 will be printed back. So when you run this, 1 will be printed back. And if you keep doing this, then the items will be dequeued in the same order in which they were inserted. So right, we inserted 1, 2, 3, and in the same order they are coming out, 1, 2, 3. However, there's a problem. That problem is that if, let's say, you get into this problem here, that is, the size is not good, then, once you run out of the size, then the pop is going to give an error, right? You get into an index error that you're popping from an empty list. So this can be a problem that you'll have to handle in your code, in your dequeue mechanism. You'll have to say, okay, if self.queue, that is, if this self.queue is either uh, it's not none and not empty, that this essentially this means that self.queue has some values, then return this. Else you can do something. You can either raise an error which was anyway raised, or you can return, let's say, none. Maybe nothing's going to be returned because it's the end of the queue. So if you run this now, the fourth value will be none. That's nobody's in the queue now. And finally, you can, let's say, print q1.size. You can do size, and you get size at this point. This is the size. Right, so very simple data structure, which is our custom data structure that we have created. It's called a queue, and it is able to implement the first in, first out behavior. It's built on the core data structure that Python provides us, which is a list, but we enforce certain mechanism on it. Any questions?
The queue doesn't have like a peak method, or I guess you could implement one, or does it make sense?
So queue can have a peak method, and usually stacks have the peak method. So peak means that essentially you're saying what is at the front of the queue, right?
Mm-hmm.
So yeah, you can just basically, instead of, let's implement a peak method right now. Suppose a person standing here wants to say who's the first person in the queue. Then what you will do? What will you do?
You want to grab the last
Element,
minus
right?
one,
So,
yeah.
Yeah, so you say peak and you say self. And you can once again write the same code. If only this is present, if only this is the case, then return self.queue -1. Essentially, else return none.
Right.
So then you can have a peak method as well. You can write, okay, let's just write here q1.peak. So you write this, so essentially you get the who's the first element here. You get that answer. Let's print it. Did I print it? I did not. Let me print this. Now, this is a very basic class that I have created, and you have to do it several times, both in real world, and you have to do this in interviews as well. Many questions in interviews are about creating a custom type of data structures that can do certain operations in certain complexity. This is not the best implementation of queue in the terms of algorithmic sense, just to keep that in mind. I'm just showing this for the Python class. But yeah, this is what we have for today. In the next class, we will be talking about operator function overloading and operator overloading, which is a form of a polymorphism. So suppose you have, let's come back here and let's say remove all of this and just say, let's just put comments here. I'll make it a string and then just say print q1. So it prints something like this. Whereas if Python has a list like this, 1, 2, 3, then if you write print L, then it prints the list. It doesn't print this random string, not a random string, but the description. The reason this is happening is because Python does not know how to print your custom object. This is why it's happening. And you can tell precisely to Python how you want your object to be printed. And that we are going to look into in the next session, which is going to be function overloading and function overriding. and operator overloading as well. More stuff. Basically, you also tell Python how to work with operators on your custom types. So if you want to write, let's say, write q1 plus q2, Python can handle that if you tell Python how to do that. That's it. That's all I have for today. And if you have any questions, you can ask me. And if you don't have any